To you all.
Yes,
Yes,
sir.
sir.
Yeah. So good afternoon to you all.
Good
Good
afternoon,
afternoon.
sir.
The next topic is Perceptron, and better you should just note down some points related to that. Take a pen and paper, and we need to do some calculations here also. Perceptron is a single layer neural network, just like a neuron. It's a single layer neural network, and multi-layer perceptrons we can call directly as the neural networks. The perceptron is a linear machine learning algorithm for binary classification purpose. So binary classification in the sense there you can have very proper separations, one and zero like that. So in that particular linear ML algorithms, we use this perceptron. It is used in generally, it is used in supervised learning. It helps to classify the given data. We come across yesterday what is a supervised and unsupervised. In a supervised, you can have the data just like a rows and column wise. Here in this algorithm, it enables neurons to learn and process elements in the training set one at a time. So every perceptron is a single one which will train and we will act based on that. So in these algorithms, we are giving some weights to each and every input signal in order to draw a line decision boundaries. So here, every input what you are going to provide, that input will have a certain weight. So randomly we are assigning some weights. Later we are modifying based on our requirements. So what exactly output you are getting? If you are not getting accurate output, means we need to update the weights and we need to repeat the same algorithm again and again. Here it enables you to distinguish between the two linearly separable classes, one and zero like that. So very particularly the things are the what you can say grouping will be done, classification will be done in this particular perceptron neural network algorithms. So here basically we're going to have two types of perceptron models. One is a single layer and another one is a multi-layer. So we will see the single layer now and we will discuss multi-layer perceptron later. So it looks like a simple block diagram added here, right? So you are providing some inputs like bias as one, it having some weight, initial weight, and there we are providing some inputs like x1, x2, and so on up to xn. And every input will have a weight like w1, w2, and so on till the last one, whatever. And every here the weights are going to be considered as the random values, random weights, and whatever the input you are providing. For example, that input is going to be multiplied with the weights, and all things are going to be grouped together in the form of summation here. So all the weights and along with the inputs are going to be summed together in the form of a summation or net input function. There you are adding, multiplying along with their inputs and weights, and you are grouping that one. You are summing that one. That information will be handed out to the activation function later. That activation function is a function which will generate some output. This is a simple scenario happens. You are giving some input along with some certain random weights. Those things are going to be collectively grouped together or summed together. That will be handed out to the activation function. That function will give you some output. If the output is our required one, so our model is working fine. If not, we need to adjust the weights. We need to go back to the previous case. We need to go back to the previous and we need to update all the weights and repeat the same model for the next iteration. So here the weight parameter represents the strength. The weight is nothing but the strength of the connections between the units. Another important parameter of perceptron components is the most important. The weights will act and adjust based on that. Weight is directly proportional to the strength of the associated input neuron in deciding the output. So if output is not accurate, if you are what you are expecting, if it is not, then we need to adjust the weights. Further, bias can be considered as a lean as the bias is the one in the previous case, one is a bias here. This is the one we are going to be considered. Bias can be considered as the line of intercept in a linear equation. So this is the initial bias value and followed by the input and its weights. And the next one, next important function here it is activation function. There are certain important components that helps to determine whether the neuron will fire or not. See here whether the neuron is going to be fire or is going to be executed or is going to be give value or not. That is going to be decided or will give the things with the support of this activation function. Usually these functions in generally three different types: sine function, step function, and sigmoid functions. So the three functions added here. The first one is the step function. There the value is positive value, either 0 or plus 1 like that. It goes on continuously, 0 or plus 1. The sine function will move minus 1 or 0 plus 1 and so on. And a sigmoid function is the one where gradually it is increasing to negative to positive and so on. So these are the functions which will be used in this particular perceptron in order to give a proper, what you can say, output or not. So actually this activation function is the one which will determine whether neuron will fire, will give output or not, or fire or not like that. So based on these notations, we will go for doing a simple calculation. So this is what we discussed in ML. Perceptron considered as a single layer neural network that consists of a main parameters where we are providing some inputs, and every input will have certain weights. The weights will be added here along with the bias value, and we are going to find the net sum, and we are applying activation function on that one. So we will see some example for this. The same things we discussed. And here one more, the same example added here, but here we are adding error value here. So something what you are expecting, but the system is giving a different value, means we need to adjust the weights. That adjustment will be done by means of an error. That value is going to be added and update all the weights. And we are taking that values and updating it along with the inputs and finding the sum of the things by means of summation function and assigning to the activation function and getting a value. If the value is not proper one, again we need to do adjusting the weights by forward bias by sending things back to the weights in appropriate error correction and go for repeating the same continuously for different number of times. See here, the perceptron model works in two important steps. The step one, where you are going to be find out the sum of all inputs along with the weights. So sigma wi into xi, x1 into w1 plus x2 into w2 and so on. All the inputs along with the weights are going to be multiplied and summed together group, and we are going to be maintain that value. And special term called bias value is going to be or is some another weight which is going to be added to the sum value. This is the first part in our model. So you are collecting all the inputs along with the weights, do multiplication and sum together. That value is going to be added with the bias value. This is the first step. Later, we need to find out, we are applying in the second step, you are applying activation function, right? So the function of f of, and you are giving this value. The system, I mean, the neuron will work or not. Whether you are getting accurate value or not, the function is going to be applied for this. My voice reaching to you or not? But
Yes,
don't
sir.
do any other recordings or any other things. Already I started recording, but don't do other things. Recording is going on, right? And మీరు మళ్ళీ మీటింగ్ స్టార్ట్ చేయడం అంటే అది ఏం చేయదండి. This also simple calculations here. Yeah. Perceptron learning rule states that the algorithm would automatically learn the optical weight coefficients. The input features are then multiplied with the weights, ఇవన్నీ చెప్పుకున్నాం అవి, and neuron is going to be fire or not. So whether you are getting accurate value or not. If the perceptron receives multiple input signals and if the sum of the input signal exceeds a certain threshold value, it either outputs a signal or does not return an output. Right? In the context of supervised learning and classification, this can be used to predict the class of sample. So we need to think of these two things and we'll go for applying the same by means of a simple application. So here having a mathematical, you can say that whether the function f of x is 1, I can say that if w, I mean weights and inputs along with b is greater than 0. So I can say that the function is going to be written 1 or else the function is returning 0. So whenever the value is the sum of all its input value along with the bias value, if it is more than 0 or threshold value more than threshold value, then I can say that the output is 1 or else I can say that the output is 0. So W represents the real valued weights vector and B represents the bias and X represents a vector of input X values. So we are going to be apply the same, the perceptron. So come back here again, this particular picture. So here you are having some bias value and we are providing some inputs x1, x2, xn up to xn, and every input will have some weight. Like that bias also having some weight, right? And so on all the weights, and you are summing all the inputs along with the weights. You are multiplying input value and its weight and grouping or summing all the values together. And we are getting a sum value. That value collectively you are collecting here the form of a net function, net input function, and that is going to be handed to the activation function. Whether you are applying sigmoid function or step function or whatever the function, and in order to get an output. If the output what you are getting, if it is getting either 0 or 1, very particularly you are having binary classification, here it is, you may receive either 0 or 1. If you are getting 1 in the sense, oh, that what you are getting accurate value. If not, what error is generating, what correction is required in order to update the weights. That correction is going to be forwarded back to this and update the weights and repeat the same algorithm for the next iteration. So we will see this by means of a simple example. So there you can have two things here, finding the sum and applying the function, activation function. That function will give you some output. So based on whether the neuron is going to be generate or fired or not, that is going to be decided by means of activation function. Once you are receiving any value, that value whether it is required one or the output is required one or not. I'll explain the same with a simple example, then you can have a clear idea on this. If you have a pen and paper, better note on the all these things. Here I'm applying, I'm verifying whether AND gate is working properly or not. So AND gate problem, the gate returns if and only if both inputs are true. So usually what happens, the AND is going to be written true or written 1 when all inputs are high. All inputs are true, I can say. Then only I can will get a true value. Yes or no? X1 and X2 both are high, both are true, then I can say that the condition is true. If anyone is false, anyone is low or 0, output is 0. Am I clear or not?
Yes,
Yes,
sir.
sir.
Yeah. So we are testing, we are finding the same truth table for AND gate by means of our perceptron model, and we will see how the weights are going to be updated randomly. So here we are going to be set weights randomly. There is no particular thing that we can set random values in between 1 and 0. So here I am setting W1 as 0.9 and W2 as 0.9. So there I am having two inputs, X1 and X2. X1 will have a 0.9 as the output weight, and X2 will have a 0.9 weight. These are the random weights. So I am considering some weights initially randomly to the inputs, and I'm going to be take the first instance. Better note down with on a paper with a, take the first instance of this perceptron. Here x1 is 0, x2 is 0. So the previous case I am taking the first instance. I'm verifying whether I'm getting proper output or not with the random output, random weights 0.9 and 0.9. Right, so lying between 1 and 0, the weight should be lying between 1 and 0. So here I'm considering in the first instance taking x1 as 0 and x2 as 0. Some unit will be 0 as calculated below. So some how I can get? So x1 into w1 plus x2 into w2, 0 into 0.9 plus 0 into 0.9, the result is 0. The sum function will give you 0. So activation unit check the sum unit is greater than threshold. If this rule is satisfied, then it is fine and the unit will be written 1. Otherwise, it will return 0. So here activation, the function will check the sum unit or the sum which is generated is greater than threshold or not. If this is satisfied, the sum value is more than the threshold value, then it will return 1, or the neuron is going to be fired as 1, otherwise it return 0. Right? By the way, modern neural network architecture do not use this kind of step function as activation. Here I am taking the activation value or a threshold value. Here it is as 0.5. Here I got a value 0, and 0 is greater than 0.5 or not. I'm going to be verified here. If it is more than that, the value is going to be generated as output 1. If not, it returns or it gives output as 0. So here the sum value is 0 and threshold value is 0.5. So 0 is greater than 0.5 or not. If it is not the case, here I'm going to be written 0 value. So the sum value is not at all more than threshold value. So the sum unit was 0 for the first instance. So activation unit returned 0 because it is less than 0.5. So we are assuming the threshold value or activation function will give you the 0.5, which is more than the sum value. So I am just returning output as 0. We will not update weight. Why? Because here what you are getting for 1 and 0 and 0, the output should be 0. So which I am getting here. So the sum value is 0, which is lesser than threshold value, which is generated by the activation function. So if it is lesser than this, so you are just showing 0 on the screen. If it is more than threshold value, then you are going to be written 1. That is the condition here. So in this particular case, assumed weights 0.9 and 0.9 will satisfy, are going to satisfy for this particular case. I'm verifying the same weights. Here need not to adjust any weights. There is no error in this case. There is no error in this case. The inputs are 0 and 0, weights are 0.9 and 0.9, and you are summing, the result is 0. 0 is not more than threshold value. It is returning 0 as output. So output is 0 in the sense that is our required one. So you are getting the same value on the screen. So there is no correction, there is no error. The weights are satisfying in this particular instance. Now I am going to be verify for the second instance. Am I any doubt in the first instance?
No,
Any
sir.
doubt in? So simple. I'm taking a very
No,
simple
no, sir.
example. Yeah, two inputs, two weights, and you are doing, right? So coming here, the second instance. Here I am taking the second instance in the second row. The x1 will have 0, x2 will have 1. So x1 is 0, x2 is 1. Getting a sum value here, 0 into 0.9 plus 1 into 0.9, the output is 0.9. I mean, the sum value is 0.9. So actually 0.9 is more than or greater than the threshold value, right? So here I am assuming threshold value is 0.5, which is the sum value is more than 0.5 means here it is returning value 1. So here it is returning 1 instead of 0. Why? Because the sum value is moving away from the threshold value. It is more than the threshold value. So the system will return 1 as output. But actually we are getting output value as 0. But the system is returning 1. Means the model is giving wrong output in the second instance. So with the weights of 0.9 and 0.9. So this instance is not predicted correctly. There is some error in this. That's why we will update the weights based on the error. So here I am going to be find the error by means of epsilon, actual output minus predicted value. So actual output is 0 and prediction is 1. So 0 minus 1, we are getting minus 1 as error value or a correction value. So we will add error times learning rate, error times learning rate value to the weights. Learning rate would be 0.5. By the way, we mostly set learning rate value between 0 and 1. So here I am getting W1 equals to W1 plus alpha into epsilon. So 0.9 W1 plus 0.5. This is our threshold value, epsilon value. Sorry, alpha value into epsilon value is minus 1. Correction value is minus 1. So here you are updating the weights by multiplying these two. So 0.9 minus 0.4. So 0.9 is a random value. I'm going to be adjust that value with the corrected value, with the correction. So I'm getting a new weight as 0.4 for W1 and 0.4 for W2. Am I clear or not? So 0.9 weight so నేను చేసిన క్యాలిక్యులేషన్ ఫస్ట్ ఇన్స్టెన్స్ కి కరెక్ట్ గా వచ్చింది కానీ సెకండ్ ఇన్స్టెన్స్ కి తప్పు వస్తుంది అది ఐఎమ్ గెటింగ్ 1 అవుట్పుట్ రాదర్ దాన్ 0. సో నాకు అవుట్పుట్ తప్పు వస్తుంది కాబట్టి దాన్ని నేను ఇక్కడ కరెక్ట్ చేసుకుంటూ వెళ్తున్నాను. సో ఐఎమ్ అడ్జస్టింగ్ ద వెయిట్స్ ఇన్ ఆర్డర్ టు కరెక్ట్ ద మోడల్. సో ఇప్పుడు నేనేం చేస్తున్నాను యాక్చువల్లీ ప్రీవియస్లీ 0.9 was a weight. Now I am going to be update with 0.4 with a new weight. Okay, Namma. So update the weights and repeat the same. Now repeat the same. So here apply the same here. So these calculations are going to be done in a different way. 0, x1 is 0, 0 into what is the value? New updated value 0.4. Yes or no? Plus 1 into 0.4. What is the value now? Anyone? 0 into 0.4, 0 plus 1 into 0.4,
0.4, sir.
0.4. Yes or no? This is a new value generated with the new weights. Right, Amma? So 0.4 is less than 0.5. That's epsilon alpha value or a bias, what you can say, function values, sigmoid function value. So if it is less than 0.5, the system will return 0 as output. So
0.
that is what you are expecting. ఇంత ముందు మనకి 0.9 weights దగ్గర మనకి 1 వచ్చింది. Now with the updated weights, the system is going to be written 0.4 less than 0.5. So newly generated sum value is 0.4, which is less than 0.5. That's the system is returning 0 as output. Means the corrected value will give us corrected value, the corrected weight will give us accurate output for us in this particular case. With the same weight, 0.4 as a weight of W1, X1 and W 0.4 for X2, we are going to be moving to the third instance. I'm verifying whether it is fine or not. So the third instance is considering X1 has 1, X2 has 0, right? X1 is 1 here and X2 is 0 here. Find out the sums. 1 into 0.4 is 0 into 0.4. The result is 0.4. 0.4 is less than 0.5. The output is false. That's why it is giving 0 as output. So this is what you are expecting here. The same value is going to be get output as 0. So x1 1 aina, x2 1 aina, x1 0, x2 0 aina, you are getting output as 0 with 0.4 weights. So there is no correction, there is no updation in this case. Activation unit will return 0. Why? Because 0.4 is less than 0.5. So there is no update for this. The weights will go on continuously for the next instance. In the fourth instance, there we can have x1 is 1 and x2 is 1. Both are high in this case, both are true in this case. And I am going to be apply an operation on these two and the result should be 1. So apply the same weight 0.4 for this case. 1 into 0.4 plus 1 into 0.4. Usually the value is 0.8. So 0.8 is more than or greater than the threshold value 0.5. So whenever the value is more than threshold value, the system will return 1. So in this scenario, the system is going to be written 1 as output. That is true in that scenario. Yes or no? In the fourth case, we are having x1 is 1 and x2 is 1. The output should be 1. Here the values are after some, the value is going to be generated with 0.8, which is more than 0.5. Means based on our condition, if the sum value is more than the threshold value, then I can say that the system will return 1. That is actual output for us. So here, whatever the value you are going to be considered, based on that value, you are applying all the inputs and weights and finding the sum and verifying appropriate output. Whether you are getting accurate output, need not to do any modifications for the weights. If something goes wrong, if you are getting something other than what you are expecting, do corrections. That corrections is so important here. So we need to do corrections by using these particular function or formula. Actual output minus our predicted value. So just separate these two and we'll get some value. That value is going to be corrected with the, add to the new weights to the existing weights by using this. So these are only things we need to remember here. So new weight is going to be added to the existing weight with the correction value along with the threshold value. That will give you new weight that is going to be multiplied with the input value and you are getting some value as output. If that value is required one, so do nothing, just proceed. If it is also giving some wrong value, correct the value again with the corrections. This will go iteratively as long as the system or the model will give you accurate result. So after fourth instance, go for the second round again. In the second round, you are considering new weights as 0.4 and 0.4. Repeat the same. Whether 0 and 0, both values are 0, whether you are getting 0 or not. Here the value is 0.4 in this case. 0 into 0.4 plus 0 into 0.4. the total, the value becomes 0 here, not 0.4. 0 into 0.40 and 0 into 0.0, the value is less than 0.5. So it returns a 0 value for this case. This is a simple diagram. Finally, so whatever the input you are going to provide, that inputs are going to be multiplied with some random weights. That weights are going to be summed together in the form of a sum unit, and the sum unit is going to be handed to the threshold function. Here you are defining or designing or determining whether the neuron is going to be generated or fired a result or not. If it is not, we need to do some corrections by updating the weights. This is forward bias mechanism. You are just coming back and updating all the weights and repeating the same process again and again until you get a proper output by means of this. Whenever you are getting accurate output, that output is going to be recorded. Any doubts so far in this?
Yes.